Hi guys, I'm live again. My phone died, but I did finish. Board's not in the right place. Let's try that again. Put the board in where you guys can see the board. All right. My phone died, but now it's charging even though it's got like 1%. So hopefully you guys can see this. We'll finish up the proof. Yeah. My phone died right in the middle, but I did finish it, but you can't tell because the phone died. So let's finish it a little bit. So I'm going to just do it fast because we can do this. So we had that the integral was the limit as h approaches 0 of it was sine h plus times cosine h minus 1 over h, correct? Plus cosine h times sine h over h. That's what we were left with when my phone died. We'll go through this. We can do this. So it's limited towards 0 of the sine h times this thing plus cosine h times this thing. We'll do them separately. Let's start with sine h over h. We can do that. We'll be a step closer. So sine h over h. What is that? Let's make h the angle. So we have some tricks we can do. Let's see. Yeah, it's a lot of geometry, trigonometry is more like. You have h is the angle. So h is the angle. And then you have this guy. We're gonna make this called O. This is gonna be A. This is B. And then this OA is 1. So OA equals 1. All right. So we make a circle out of this, which has a curvature to it. And then you have a point where the curvature, where's my eraser? I didn't even have it. There you go, space brain. This is going to be 1 down here too. It's going to curve at the circle of 1 here, and then there's going to be a line here that's less than that arc. But this is going to be called, this is B, this is C, and then I'm going to say that that OA is 1, and so is OC. OC is also 1. Okay, fair enough. Now this arc here is this arc of AC equals H, because that's the definition of radian measurement, but times OA, because it's radius. It's the angle times the radius is the arc you make out, and this arc is arc AC, which is H times OA, but OA is 1, so that's equal to H. So the arc is H. So we know this arc is H, and we know that the arc is H, arc AC equals H. All right, we know that. And we know that we know this trick. We know that sine of h equals something cool. You go up like this, and then you have the circle goes on. It's not a very good circle, but the circle is going to curve, and this goes up like this, like that, and you have sine h equals sine is always the y thing divided by the hypotenuse, or the longest one. I'm going to write that as, I'm going to make a point here. I'm going to make like a this is the circle. It continues up like this, and not like I started to draw it, more like that. And you have an angle that goes across the circle. It kind of goes, this goes like this, and then this line cuts it in like that. You make a radius to that point and there to that point, and I'm going to call this point E. And I'm going to call this point up here D. So there's our points. So we're looking to do some stuff. Let's see what we can do. H is this arc. Sine H is such that sine H equals sine H equals, let's not go that far yet. Let's do this. Let's say that CA, let me think. OA, OD, sine H over H. I'm sure I know what I'm doing here. Yeah, I do know what I'm doing. Yeah. Arc and the angle. H is, and the sine H is interesting because it is CD sine over OD. Sine H is CD over OD. Okay. What do we know about that though? Sine H. We know that, I do know that, right? Yeah. Yeah, we want to know sine H over H, CD over OD. And CD OD and OD. Okay, we know this. We know C. I don't know what I'm doing with that though. I will though. I will. Arc AC equals H. And that arc and H is greater than CA. because CA is smaller than the arc. But H is less than CE plus EA, because that's these two longer lines. But EA is because of a equality, because of this being a hypotenuse and this being a right angle, EA is less than ED. Okay, so if H is less than CE plus EA, then H is also less than CE plus ED. H is less than CE plus ED. Yeah, so H is less than this, but yet H is the arc of AC, which, okay, which is H. What's that line there? What is that line? AB. What is AB? What is AB? Gotta figure that out. Oh, I know. Wait. What is CA? I meant. Which is greater than CA. Anyway, BA, let's do this. BA BA equals sine of H. Just does. Because this is BA over OA. OA is 1. So BA equals sine H. All right, that works for me. But BA, which is sine H, is less than the arc of AC, which is the arc of AC is H. So sine of H is less than H, because sine of H is BA, but BA is less than this arc of AC, which the arc of AC is H by radian measurement, because H is the arc is the H times the radius is equal to the arc. And since the radius is 1, H is equal to the arc. So if arc AC is H and sine H is less than H, because sine H is less than arc AC, which it is, then we have a little thing we can do. We can say sine H divided by H is less than 1. Divide both sides by H. Sine H divided by H is less than 1. That's important. Okay. But what else can we say about the sine H and all that? We can do a little trick here. We can do so. We know that. So we're partly done. We got to do tangent. I'm going to I'm going to erase some things so we can write some more. Let's erase, we know this. Let's erase it up here. Something tells me to do that. Well, I started erasing. I think I'm gonna erase this too. Let's erase the whole thing. I'm gonna be bold. Okay, so we have sine h over h is less than 1. But we have to figure out one little trick to do here. Tangent h equals CD, wait, what is it equal to? Tangent h equals sine h over cosine h. That's just the true thing. And tangent of h is equal to also CD over OC. It's this big thing up here divided by this longer thing down here, which is OC, and this whole thing up here is CD. All right, let's go with that. So yeah, so tangent, but what do we know? What do we know? Well, OC is the same as OA. They're both on the circle, so OC is 1. So that means that tangent h equals CD. It's just that length, because that length divided by this is the y over the x, and since the x in this case is 1, because OC is equal to OA, you have tangent h equals CD. All right. But also tangent, therefore, sine h over cosine h, which is tangent h, equals CD. So we have sine h over cosine h equals CD. And we have CD equals, what's CD equal? Let's just figure this out. CD is equal to, CD equals CE plus ED. We know that. Fair enough? But we know that CD equals CE plus ED. But CE plus EA is greater than the tangent, than the arc AC, which is H. CE plus EA is greater than H. But ED is even greater than EA. So it implies also then that CE plus ED is also greater than H. All right, got that? Okay, CE plus ED is greater than H. What are you going to do about this? Let's see. H greater than H. H. But I had some identity. Tangent H is CD. So CE plus ED is greater than H. But tangent H is CD. So CE, so what you can do, if CE plus ED is greater than H, but CE plus ED is CD. So you have CD is greater than H, but CD is tangent H. So therefore, tangent H is greater than H. But tangent H tangent H equals sine H over cosine H. It's a trig identity. But tangent H is greater than H, so sine H over cosine H is greater than H. All right? But sine H is greater than H over, yeah, right. B. I'm going to do the right math here. Therefore, sine H is greater than cosine H times H. But then sine H divided by H is greater than cosine of H. Simple math. Here's the thing. If sine H divided by H is greater than cosine H, doesn't look like an H to me. If sine H over H is greater than cosine H, but sine H over H is less than 1, then we're getting somewhere. So let's even trash all this for now. Don't need it right now. It's going out on a limb here because we have our 2 points we needed right there. See that? Watch this. Watch this little trickery thing. So sine H over H is greater than cosine H, but also sine H over H is less than 1. But this is all as H approaches limit as H approaches 0. But the limit of cosine H as H approaches 0 is 1. So I have sine H over H as H approaches 0 is greater than 1, but also sine H over H is less than 1. If it's greater than 1 and less than 1, then is equal to 1. So sine H over H equals 1. Why do we care? Because sine H over H is equal to 1. Then this little contraption here, cosine H times, if this is 1, then that's just equal to cosine H. So we're getting, now that becomes cosine H. So now we have that the derivative is of sine a derivative of sine theta is the limit as h approaches 0 of sine h times cosine h minus 1 all over h plus cosine h. I mean, wait a minute. Wait a minute, second. Let me just make sure this is right. It might have been, actually, I mean by this, I meant that this is sine theta right here. Sorry, guys. This is sine theta. This is cosine theta. The h was the other parts. So it's sine theta. I started out wrong. Sine theta times this plus cosine theta plus the sine h over h, which then makes this cosine theta. This is sine. I left the problem here. Sine theta plus this plus cosine theta times that as h approaches 0. So it's sine theta times that plus cosine theta times what I just showed to be 1. Sine h over h is limit as h approaches 0, sine h over h is 1. So cosine theta times that is cosine theta. Sine theta times this is the rest of it. We just have to figure out what cosine h minus 1 all over h is, limit as h approaches 0. See, so I just wrote that. I wrote h and h when I should have wrote theta and theta, but then these are h's. Sorry about that, guys. So now limit as h approaches 0 of cosine h minus 1 all over 1. What are you going to do? Let's do that. I started off with a typo. That's all that was. Okay, so now we have this, which I wrote here. This is 1, so this just becomes this just becomes cosine theta. That's this part right here. We're working on this part now. So let's do it. Limit h approaches 0 of cosine h minus 1 all over h. What are you going to do? Multiply top and bottom by something. Do this. Limit h approaches 0 of cosine h plus 1 minus 1 times cosine h plus 1 all over h times cosine h plus 1. You multiply top and bottom by cosine h plus 1. And you get some good results. This top part becomes cosine squared h minus 1. Bottom part becomes h times cosine h plus 1. Yeah. So what do you do now? Well, let's check it out. Let's erase some stuff up here. Start up here again. It's sine squared h plus cosine squared h equals 1. It's a trig identity. Therefore, cosine squared h equals 1 minus sine squared h. So cosine squared h minus 1 equals minus sine squared h. So this is minus sine squared h, which allows us to say that let me think about this for a second. Yeah, that this then equals this part here equals minus sine squared h all over h times cosine h plus 1. Because this is all minus sine squared h. See that? So now the problem, come on. Yeah. So now the problem becomes you have the sine theta times now is times minus sine squared h all over h times cosine h plus 1. Make the sign minus on the other side of the sign, so you have minus sine theta times sine sine h all over h, because that's this part with half of that part, times the rest of the half of that part, which is sine h all over this part, which is the cosine h plus 1. So far so good, but this is all times. I mean, no, wait. Yeah, it is. Yes, it is. It's times, not plus. It's times. Minus sine theta times these two things. Sine h over h is 1, as it limit as h approaches 0, sine h over h is 1. We already determined that earlier in the video. So this becomes 1. In fact, let's cross out what we don't. Let's cross out some of this so I can say it mathematically, not just verbally. So I have, now it's minus sine theta. This is 1. So the limit as h approaches 0, sine h over h is 1. So I have times 1. And then times sine h over cosine h plus 1, limit as h approaches 0. So sine minus sine theta times 1 times the limit of this as h approaches 0. What's the limit of as h approaches 0? Sine h is 0. That's going to be a 0 there. The limit as h approaches 0 of cosine h is 1, plus the 1 is 1. So this becomes 0 over 1 over 1. Fair enough. Therefore, this becomes minus sine theta times 1 times, let's write it down here so I can look better, becomes minus sine theta times 1 times 0 over 1 plus 1, which then is minus sine theta times 1 times 0 over 2, which is minus sine theta times 0. So this becomes 0. This whole thing, because this is 0, and this is minus this times 0, this becomes 0. So we have the limit as h approaches 0 of sine of 0 plus cosine theta times this, which is 1. Therefore, if y equals sine theta, then dy dx, or f prime, dy dx equals cosine theta. So if y equals sine theta, the derivative or dy dx of sine theta is cosine theta. We just showed that. And that was kind of tricky, but I cut off on the first part of the video, and I finished it on the second part with one small typo at the beginning, but that's the gist of it. So if y equals sine theta dy dx equals f prime of x equals y prime equals cosine theta. So love you guys, peace, love, and rock and roll.